Good afternoon, students. Today we're going to start talking about rational numbers. Now, most of these things you should remember from last year, but we're going to go ahead and go over the vocabulary and the definitions of our different types of rational numbers. You should have your handout that's green that has space for you to write in your vocabulary words, your definition, and your example. So as long as you have that with you, we should be all set. It's going to look like this. Except you don't have anything written in yet. So let's go ahead and get started. We're going to start by first talking about, of course, the term natural or counting numbers. Natural and counting numbers are positive whole numbers. So you can think of those as the things that you can count on your hands. You can start with 1 and go all the way to infinity, but that does not include 0 because we can't count 0 on our fingers. The next one, and remember you can pause this video all the way through so that you can have enough time to write down and you don't have to keep up with me, so pause as you need to. The next one we're going to talk about that you need to write in on your paper is whole numbers. Whole numbers include a positive whole number or 0. So this is only going to be the positive side of our number line. So it's going to be 0, 1, 2, 3, etc. all the way to infinity. Those are considered whole numbers, and it is only the positive whole numbers and 0. Our next word is integers. Integers are the set of whole numbers and their opposites. Last year we talked about in 6th grade 4, the whole number 4, its opposite would be negative 4. So integers are going to include positive whole numbers and negative whole numbers. So you see in parentheses I have a shorter definition for you there, which is all positive and negative whole numbers. Those are called integers. Finally, we have the definition for rational numbers. Rational numbers are all numbers that can be written as a fraction. And the denominator in that fraction can never be 0 in order for it to be a rational number. So for instance, the whole number of 2. Last year we learned that we can write the whole number of 2 as a fraction by putting it over 1. So since we can write that whole number of 2 over 1 as a fraction, that means it is a rational number. Now, something to note here is that repeating and terminating decimals are in fact rational numbers also. So that's something to keep in mind. If a decimal repeats, it's also a rational number. If the decimal ends at a certain point, then that's also a rational number. Now, after hearing these definitions, do you think that a natural or counting number is a rational number? Can we write all positive whole numbers as a fraction? I think we can, so those would probably be considered rational numbers. And whole numbers, can we write all positive whole numbers or 0 over as a fraction? I'm sure we could. Okay, so that would also be considered a rational number. Even integers, if I have negative 2, could I write that as a fraction? Well, yes, negative 2 over 1 is still just negative 2. So that is also, integers are also considered rational numbers. And we'll talk about the relationship between all of these in class tomorrow. Now let's go ahead and continue. We do have a little bit more definitions, and we do have types of decimals. Now this is not something that you have room for in your table. I don't want you writing the definition of these decimals in your table. You can actually write that below the table on your paper there. So we have two types of decimals we're going to talk about. The first one is repeating decimals. Repeating decimals are a decimal whose digits repeat in groups of 1 or more. Last year we saw and used some repeating decimals. When we have a repeating decimal, we use what's called bar notation to represent the repeating digits. We draw a little bar above the numbers that are going to repeat in our decimal. Without that bar, nobody will know that that number is supposed to be repeating, and that's a very important thing. Our second type of decimal is terminating decimals. Terminating, if you think about what the word terminate means, that means to stop or get rid of something. So a terminating decimal is a decimal that does not repeat or go on infinitely. So it's going to have a definite ending. For instance, 1/2 as a decimal is 0.5 or 0.50, and it ends right there. That would be considered a terminating decimal. Most of the decimals that we use are terminating decimals. These two types of decimals, remember, are rational numbers also. So that's something to remember, and you should have both of these written below your table on your notes. Now, Let's talk about irrational numbers. This is the last definition you need to write inside of your table. Okay, the last one inside of the table. An irrational number, hopefully you can imagine, would be a number that cannot be written as a fraction. So in other words, it's all the numbers that are not rational. So if I cannot write a number as a fraction, then it's not going to be considered a rational number. It's going to be an irrational number then. Okay, make sure you have all of these definitions written in. If you need to go back from the beginning of the video and pause again to make sure you have everything, please do that. Your last thing on your homework tonight is a bit of a quiz. Quiz time. I want you to go ahead and look at each of these numbers. So for each of the number, you're going to decide what name or names to give it. You're going to write each of these numbers in the correct spot or spots on your piece of paper there as an example. So you see on your notes page there's a column at the very end for examples. I want you to look at 3/4 and I want you to tell me, where would 3/4 go? Could I write it in the whole number spot as an example? If not, then you want to not put it there. Maybe it's only a rational number. Maybe it's not an integer, a whole number, or a counting number. So I would probably only write 3/4 in the rational numbers example. Okay, some of these you'll be able to write in more than one spot, and I want you to go ahead and write them in as many spots as you can according to the type of number that they are. Okay, we will go over these in class tomorrow. So make sure you have this done. You should have all 5 of your definition boxes filled in your table. You should have your examples listed. You should also have your decimal definitions below your table in order to have your... Okay, now for my pre-AP kids, you guys have a little bit more to think about today. Not too much more. Still a review from last year. So let's look at the other page that you actually got. Now, the other page that you got is going to help us think about sets and subsets of numbers. And we'll talk more in depth about that in just a moment. On your paper, you should see a diagram very similar to this paper. We're using this as a type of Venn diagram. And what we're going to do is first start by labeling each part of the Venn diagram with one of our types of rational numbers. So on the outside part, the biggest part of our Venn diagram here, which does contain other sections, hopefully you would think that we would label that as rational numbers. Okay, because like we talked about on the previous screens, and like you're starting to probably think about at home, is, you know, those whole numbers are considered rational numbers. So maybe whole numbers would go in one of these smaller sections of our Venn diagram. So if our biggest section is rational numbers, then the next section of our Venn diagram should make sense to you that it would be integers. Okay, so here's where we would put our integer section. And you should be labeling these just like I am on my Venn diagram. Then the next section is going to be our whole numbers. Okay, finally, our whole numbers then leads us to our natural or counting numbers. Now when we look at these sets, it should actually make sense to you then that our natural counting numbers here in the very center are actually also going to be able to be named whole numbers. If I had 1 as one of my counting numbers listed in this Venn diagram, then I think all of you would agree that 1 could be called not just a natural and counting number, but a whole number. Remember, our definition of whole number was a positive number, or 0 is a whole number. So 1 would definitely be one of those whole numbers. Now, is 1 also an integer? Well, yes it is, because integer's definition was positive and negative whole numbers. So 1 can also be called an integer. And then rational number is also another name that we can give 1, because the definition for rational number was we could write it as a fraction, and we all know that we can write 1, the whole number, as a fraction by putting it over 1, because 1 divided by 1 is still just 1. So hopefully this gives you a bit of a better understanding of how our Venn diagram works. Now you may be wondering what this other section to the right is for. Well, that's actually going to be for our irrational numbers. And we're going to talk about that more throughout this school year with you pre-AP guys, you kiddos. So again, what I want you to do on this Venn diagram before you come to class tomorrow is I want you to go ahead and place those example numbers that you used on your vocabulary page, And I want you to go back to that quiz section or those numbers, and I want you to now write them in all the spots that they would belong on the Venn diagram. Should be pretty easy to do looking at your vocabulary handout where you had the examples written. You're just transferring them into this visual representation of all the different names that we can give to our numbers. Okay, kind of like we have first names and last names. Well, the number 1 is going to have a lot of names. It's going to be called a counting number. It's going to be called a whole number, an integer, and a rational number. It has 4 awesome names there. Okay, so remember, you can pause this and go back as you need to, but make sure you have those example numbers written into your Venn diagram. Last thing that I want you guys to do that will be pretty short and simple for you, but I just want you to think a little bit. I want you to flip your paper over onto the back of your Venn diagram, and I want you to jot these follow-up questions down. Number 1 is, are all whole numbers integers? I just want you to think about that question looking at your Venn diagram. Can I classify and name all and any whole number as an integer? Tell me yes or no. What do you think about that? Number 2, you'll want to write this one down also, and remember, you can pause the video whenever you need to. Are all integers whole numbers? So now we're looking at it a little differently. If I look at my Venn diagram, are all integers considered whole numbers? I want you to tell me yes or no, and maybe why. Number 3 is, are all rational numbers whole numbers? Again, look at your Venn diagram and think about where rational numbers is placed. Would all rational numbers be considered whole numbers? Also use the examples to help you answer that question. Then we want to think about, are all rational numbers integers? Very similar to number 3, but just a little bit different. Again, tell me yes or no, and maybe why or why not. Your last follow-up questions is, how many names can you give the number -4? And I want you to list those. Can we call -4 a natural or counting number? You tell me. What names in our rational number family can we give that number of -4? Okay, guys, once you have all this done, you are set for your homework for tonight. Make sure you have both of those pages to bring into class tomorrow, and then we'll go from there. Have a good rest of your afternoon, and we will see you tomorrow.